Hello, everyone. Really a pleasure to be here because we, three of us, working together for several different projects in the last 2 years, and this is actually one of them. We thought could be interesting not just because the techniques, but also the business angle of it. And just kind of a little bit myself, again, just like Ian, my accents kind of like also tell me I'm coming from US, and the spirit. Usually, people coming from the other side of the Atlantic Ocean is we like to gamify a lot of things. So when I say gamify, if you, a lot of you probably try many different mobile apps that try to test what kind of personality you are, right? If you see like a mobile app that kind of show up, if they show you a picture and they will ask you, did you see the birds or do you see the tree or do you see the leaves? And based on that, they will say, oh, you are this type of person and so on. So in the past few years, I worked very closely with Spotify to understand how should we actually understand the type of personality based on the music that people pick and based on what they listen. I mean, that's very common today. Everybody use that, and actually, as a matter of fact, they use that for advertising. And then on one hand, the other angle that I thought that how can we leverage music is such a transcendent thing in everybody's, if you like to listen to music. It is really part of you. So then we kind of thinking, well, let's brainstorm a little bit. What would be something we can gamify to learn two things from the user. One, if they give us the music that they like, but we don't want to just say, oh, good, because you listen to the music, you are the type of that person based on emotion and so on. We also want the user say, how can I take the music that I like and I love and then make that become part of something that I also feel appreciated. And then we say, maybe that's fashion. So this is kind of the brainstorming that we started, and that's why we call this. So the idea initially is to basically say, if we create a website and let people like having the fun and having the enjoyment, that they can tell us, hey, here's the music I like from YouTube or something. And by the way, I also like this fashion style. Can you take the spirit of that music and then make it apply to the fashion? So again, that's just kind of gamify. And the reason, imagine if I have a user tell me these two things, and then they just kind of keep playing this, the music and then the fashion style, the music, the fashion style. It's almost a psychological test, right? To know that the kind of person, what kind of person you are. Are you always listen like a rock and roll? And then, by the way, what kind of fashion person are you? Maybe you are completely different, unlike the music that you are too. So a little bit contradict. We call it bipolar. We don't know, right? But that's kind of interesting personality as well. So this is kind of how it started. We want to gamify this kind of idea. And then, so that's kind of how we sort of kind of blend this two, the fashion clothing and the music together. So, okay, now we have this idea, but kind of think about if I have a music, and now I want to find, okay, how do I take the music and then say there's a spirit represent that music if I know the emotion? So the idea then we basically said, well, let's go to Google because Google is the easiest one, Google search. If you say, well, I think this music, we know this music represents something a little bit sad, a little bit cheerful or exciting. So what type of images represent this kind of emotion? Of course, it's a little bit subjective, right? This part is a little bit subjective, but at least we based on crowdsourcing, right? So Google tell us, when you say, I'm actually happy, I'm actually cheerful, what are the top search images is that? And that is like our representation of the emotion, and there are actually quite a few of them. And then Wojtek will probably talk more later. And then later, we take that, and then we basically said, now we have this fashion styling, and that represents different kind of emotion. Then that's where the style transfer come into play. Then we basically take that and then say, well, if that represents you are a certain type of person, you are the certain type of emotion, then we translate that into either the street style or translate to a particular product. Now, of course, there's a lot of different things that we can play in terms of style transfer because it's quite a lot of academic paper. There's also quite a lot of code already in the GitHub. But we also think about what are the different variations that we can actually create, not just the typical fast style transfer or the GAN transfer. There's already a lot of them out there. It's also like, many of this style transfer are actually very based on the covariances, the gray matrix kind of style, kind of techniques. But how can we do that at the same time still retain some parts of that pattern fabrics at the local area, not just like a global, which is what we find out in a lot of style transfer today. You lose the local intentionally because that's what most of style transfer does. And then you actually gain the global. But here we want to gain the global transfer, but still maintain some of the local so we don't lose the little fabric. And Walter will cover a little bit more, and that's kind of what we think something interesting to share as well. So now I'm going to let Pawel talk about the interface, and later he will also do a demo.
At the end, right.
if it's working, thank you.
So as the input of our idea, there are two types of inputs. Actually, one of them is a product image. So we'll try to find and style transfer the product itself. And the second one, which is more ambitious, is take a look at style from street photos. The photo that you see right here is a typical street photo, and we want to do something with this. And actually, we tried to segment all the clothes and apply the style to a particular set of clothes. Or as you can see here, we apply the style transfer to jeans only, or the tops. And on the second part, there is also a music video that we take as an input to this algorithm. So from the music video, we extract the mood of the music, and then we apply it to the left part. So as you can see, these are examples of how this particular product merged with those two videos here. On the left, you can see something more cheerful, and on the right, you can see something that is maybe not blue as sad, but it's green, and it invokes some emotions already. And here you can see that actually this model was segmented first, and we can see the tops. The blouse has different, more cheerful style, and on the right you can see this more kind of nostalgic style. Yeah. And the interface, actually, I will show at the end. The interface looks like this, so you can have inputs for both music videos and the products themselves, or street fashion. So it works with any kind of input. If you give an URL of an image, it will take this URL and process it in the background and show the results. So now Wojtek will tell something about the internals, because actually this interface may look simple, but underneath there are a lot of things going.
Yeah, so now I will delve into the technical details. On a very high level, we have created a service which enables one to transfer a style or a mood from a video to a product, either an image, either a product or a street style. We have chosen a set of styles which, in our consideration, represents different moods, and we have created a music classifier which will attribute a certain style to a certain mood genre. So the first thing that we need is the data processing method. Afterwards, we need a method to classify music genre. Then the style transfer part, which styles the image itself. And depending on whether the image is a product or a street style, an image segmentation method is applied. First, the data processing part. We download a music video from YouTube, but the video style itself doesn't interest us. We are only interested in its raw audio. So we extract the raw audio path, and then we transform it into a set of Mel-scaled spectrograms. And we have decided to use spectrograms because it enables us to make use of two-dimensional convolutional neural networks. So the model that we chosen to use is VGG16 with added batch normalization. We have also decided to use multi-label classification of genres because the genres are non-exclusive. For example, a certain artist can be tagged as a pop rock artist. So multi-label classification enables us to capture the relationships and the interdependencies between the genres at a much more finer level. We also decided to split the song into 10-second samples because of the GPU memory constraint, and also in this way we were able to create more data samples for model training. So the basic VGGA architecture, which is a very basic convolutional neural network consisting of convolutional blocks and pooling layers. We have added batch normalization because it sped up the training process. The style transfer is the part on which we have spent much more time in order to fine-tune it to achieve very interesting results. The style transfer in general is based on choosing a single style image and training a model with the use of this single style image and multiple content images in order to achieve a transferable style representation. So the style features are extracted from the style image, and afterwards they can be applied to a chosen input image. So, like I said, source of style is a single style image. Multiple content images serve the purpose of model training. The model will learn a latent style representation, which will enable it to transfer the style features, such as color and texture, onto a new product. And the gram matrix serves as style feature representation, as Carey said before.
One other thing.
It will activate itself. It's automatic.
One other thing that kind of came out. I got too many microphones. One of the things we learned through this process, I find also interesting, is not every style applied to content looks very obvious. Just because if the content images and the style images has a very similar global grams relationship, then when you transfer it, obviously, right, you won't see much of the style. And you're probably going to see this even the same thing when you do like a game transfer, all kind of thing. So one thing right now is more kind of empirical, but we're also trying to come up some kind of mathematics that, to basically understand how do we, through some sort of kind of, whitening and some kind of coloring transformation to understand how can we find the best style that has the furthest difference, from the content, from the covariance grandmasters point of view. And that's something we're still experiment. And that's why, right now the example here is definitely is the best representation, but not all of them is like this.
So we have chosen to use the file style transfer PyTorch implementation, but we have added some modifications to it, which will be described a bit later. In general, this fast style implementation is based on two models. First, VGG16 is used as a feature extractor. It is a network which isn't being trained, and it is being initialized with ImageNet weights. Then we have a transformer model, which acts as stylizer. It enables to capture high-level semantic structure of the style and content images, and its architecture is autoencoder-like, when the representation is first compressed and then decompressed to achieve the best representation. This is an architecture which makes use of instance normalization in order to make the content images onto which the styles are being transferred not prone to different contrast. One of the novel modifications that we have made in our project is the addition of style presets. We have sets of features extracted from the VGG16 feature extractor, and each VGG block will contribute a feature set. Therefore, we are able to give different weights to different feature sets in order to obtain different representations of style. So we have created 3 presets. Medium is the default presets where weights from all layers are weighted equally. And then we have created low and high presets where layers from either low or high layers are being weighted much more highly. And the low preset in general is able to capture much finer and much more granular style features where the locality of pattern is being emphasized. It also retains much more information about the structure and the color attributes of the style. Whereas the high preset stays in contrast to that, where it learns much more global style structure with high-level semantic features which are much more harmonized on a product or a street style onto which the style is being transferred. It also loses information about colors and the local structure. This is best shown based on the examples. Medium is the reference scenario, and in the column with low preset, we are able to see that the pattern structure is being captured at much more higher level, with much more local details and differences in colors between parts of the bag. In the bottom row, we are also able to see that the color varies much more greatly on the back than is the case in the high preset, where either the style pattern will almost completely overlay the bag, and in this case, even part of the content structure is being closed. Also, the color features are being much more global, with less variability in local areas. The second set of examples proves that, where either the color has more local variability or the pattern has more local variability in case of low preset, and the structure of both the color and the pattern, which will be much more global in case of the high preset. The second novelty is the style content loss, which Carey will describe.
So on this one, as you can kind of imagine, as I mentioned earlier, a lot of this style, even you take the lower layer, given the way that how the grandmasters works, that's kind of most of the mainstream way that working, regardless how the neural network is. But the learning is end up to breaking apart the local structure, and that's why the overall style get transferred was the global pattern. But we also think that from a business point of view, right? Let's say if you have a style image that has like a very detailed structure, you really want those detailed structures somehow, transfer and apply. And you don't want to lose too much of that, even though global pattern can take over. For example, if you have like a heart, you have a style image that have many hearts that represent you are exciting right now, as an example, right? You don't want that structure gets losing too much, because otherwise you just become a lot of red bubble, then you lose the original shape. So in this case, we introduce a hybrid loss. Actually, on the style image itself, we also treat it as a micro content. So in addition to the original content images, and then combine this together, we end up basically, we still emphasize the original content, so because that's your key shape, and then you have the global style, and then plus a little bit of the local style content itself, and then that's kind of how Wojtek going to show you the example of this. So this is like without any tuning, this is how it is, and then the next one is the example was a different way of how we actually introduced the third hybrid loss into it. And I'm not sure the light can kind of let you see it, but you can tell from the original one all the way to the higher weight. The shape, the local structure is become more and more obvious. And this is kind of, again, from a kind of mood transfer point of view, we just like to retain some of this, detailed structure. It could be important for some people, and that's an interesting learning from this.
Now comes the segmentation part, which was split into two parts. First is the product segmentation, which is much more simple. It is based just on thresholding and contour finding of the product. This three-stage segmentation is a much more elaborate approach because the setting onto which it is applied is much more difficult. So we have decided to base this three-stage segmentation on a neural network approach, where we have decided to use an architecture which is based on UNet. So it has an encoder and a decoder, and as an encoder, we use Inception V4 with ImageNet weights, and the decoder consists of basic convolutional batch normalization blocks with upsampling layers. We also added conditional random fields to which are being applied on the final segmentation maps. This enables us to improve a lot the final output masks, because it removes local inconsistencies such as holes or artifacts. So the product segmentation is quite simple. In the case where we transfer the style from the original, where we apply style transfer on the original picture, the style will be applied both on the product and the background. And the change of background changes the perception of the product. And you would like to avoid this, so we created a method to segment out the product, which is based on finding contours of the product based on the original image, extracting the mask, and afterwards applying this extracted mask onto the final image. So we're able to achieve a styled, segmented product with original background retained. This three-stage segmentation is a much more complicated approach. We start with an original image of a street style. Then we segment clothing pieces without the model and the background. We apply style transfer to them. And then we are able to choose only clothing parts to which we would like to transfer the style. After we have chosen those, we overlay the chosen masks with the style transfer applied onto the original picture, so we achieve a segmented styled image. The street style segmentation model is based on the Inception V4, which acts as an encoder backbone. The features are being extracted from 5 intermediate layers. The first set of features comes from the STEM module, which acts as a pooling part, which compresses the input representation, in order for the deeper layers to have much less parameters. And then the four next sets of features come from the Inception blocks. For the decoder blocks are quite simple. Those are just convolutional layers with batch normalization, leaky relu as decoder activation function, and upsampling layers. We have also introduced squeeze and excitation block in the center and just before output segmentation map to improve the segmentation predictions. The model is trained with binary cross entropy, which causes it to output masks containing n channels, where n corresponds to number of classes. This was the chosen approach because it allows us to extract certain segmentation masks for parts of clothing which do interest us, and we can freely combine them or remove certain parts onto which we don't want to transfer the style on. We have also used conditional random fields for smoothing the final predictions, like I mentioned. The user is able to choose the classes onto which he would like to transfer the style through our web interface. The results speak best for themselves. So here is presented an image of a woman wearing an orange dress with a lot of persons in the background, so it isn't an easy image to be properly segmented. First, we extract the background and the model masks, and those allow us to remove the noise from the model and to let it better concentrate on certain clothing parts. It also allows us to apply a certain trick, which will be discussed a few slides later. And the model is being able to extract both the background and the model mask pretty well. It is also able to find a head of another person which stands in the background. The clothing parts masks are also being very well segmented in this case. We have chosen to extract 3 clothing parts, which is upper clothes, so tops, the pants, and the shoes. And in case of all 3 classes, the segmented masks are being pretty well found, where the masks shown are raw probabilities without being thresholded yet. And when we apply those the chosen style onto the chosen clothing parts, we achieve this kind of a result, which is a very nicely styled dress with a gold pattern overlaid on both the dress, so consisting of upper clothes and the pants part, and also on the shoes.
So one of the ideas we're also talking is maybe instead of dress, we can change the hair color for the emotion as a more geeky idea.
And this should be possible. So let's say a few words about what worked and what didn't work during the street-style segmentation approach. The first thing that didn't work and it brought quite bad results was training a softmax output model with cross entropy. In this case, you have to attribute each class to different pixel values. And if you want to output all classes in just one mask, then those pixel values should be very different from each other, or the model will interpolate between them, and it will be very hard to create good final masks. Also, the loss function which worked the best was basic binary cross entropy, instead of, for example, dice loss or Lovash loss. We also tried basic morphological operations for street-style mask smoothing, but finally the CRFs gave much better results. This was probably due to the fact that most of the artifacts created by the models were bigger than just an area of few pixels, and basic morphological operations such as binary closing or opening were able to correct just for those very little artifacts, or either the structure of the masks themselves would be changed, which wasn't desired. Also, addition of pyramid features when you concatenate sets of features from different depths of the model didn't work very well. But there were some things that worked, and they finally gave us a possibility to improve the final predictions masks in a significant way. The addition of additional background and model masks enabled model to concentrate better on the clothing parts. And also there is this one trick which I mentioned earlier, and it is based on extracting just the background mask from the original picture. Afterwards, we apply blur on this background mask, and we overlay the blurred mask on the original image. And afterwards, we segment clothing parts from this blurred image. This significantly helped us, and probably this is due to the fact that in our training set, most of the images consisted of a model which was standing in the center of the picture, and the background was slightly blurred with non-very significant or very interesting objects. The addition of squeeze and excitation blocks also helped. They enabled a model to add global context to local additional convolutional features. And also, we finally decided to use medium-sized models because they were giving much better results. Those are models such as Inception V4, which is being used in current version of the service, or ResNet 101 with added squeeze and excitation blocks. Very heavy models such as CNET or Inception ResNet V2 didn't give us very good results. This can be probably to the fact that our training set consisted of only a few thousand images instead of a few dozens of thousands. And also, what is the most important, I think, because we assume that the final segmentation masks should work well on very different input images, we finally based our assessment on qualitative human-based masks assessment. So even though the metrics measurements such as intersection over union should give a very good proxy of the segmentation quality, finally, what gave us good results on different images was just basically checking model output on, let's say, a few dozens of very different street-style pictures. I will finish this with a few examples which show how we can achieve very interesting street-style transfer. The first style transfer results in a very interesting roses-like pattern overlaid on the dress. The second example shows a fire-like structure applied on the coat. And in this case, the segmentation mask is almost perfect, where we can see that even the edges of the coat are being very well segmented by the model, and the style is not being overlaid on the bag itself. And the third example is much more subtle than the previous ones, where we segment out the dress, and we end up with a very interesting gold pattern with pattern looking like tips of the arrows, for example. And now we will get to the live demo of the service.
So this is a great example when the content and style, their grain is very close, and that's why you don't see a big difference. And another thing what I mentioned also, during the segmentation, CRF is very important in the final smoothing. We research quite a bit. Of course, CRF is very mainstream in the segmentation nowadays, but there's also many different structures of CRF. Also used in text mining is basically the whole kind of the linkage CRF, but there's also a lot of different structure like a dense. More expensive, but I think we still want to experiment more on how to make it even better. But that's kind of also one of the key elements. So Pawel, please make it work.
So yes, so this is so that you believe it works. Let's hope a live demo is not a mistake in this occasion. So the first part, as we have said, the input is a music video from YouTube. There is no caching layer, so it is downloaded straight from YouTube. So sometimes YouTube changes things, and we get nasty surprises sometimes. But let's hope today it works. So I chose this video, and then I have examples of products. Let's choose this one. And then for the product, the settings are that we can only select what preset is used. So you remember that those presets are give you different types of outputs. So let's try this medium one.
Okay, so this will take a few seconds, so I can say about a few problems which we encountered lately with the YouTube API. So we are querying the YouTube in order to download a music video. And lately, it seems like the YouTube changes its pattern of names. So we wanted to try whether the service will work before the presentation, and then we suddenly, after a week, we turn it on, and an error appears. So we have to check. Okay, so let's look at the library which we use for the matching the names. Maybe there will be some pull issue or an issue. So maybe a pull request or an issue which will help us. And fortunately, there was one. So the day before yesterday, we were able to fix it, and therefore we were able to present the live video. Sorry, the live.
So that you believe
demo.
it works, I selected another product with this style. I can then change the preset, so we can see the difference. Oh, sometimes it blinks. Yeah. You can see that here the pattern, the style that was is dominating the image of the product itself. So you can see that almost the style, like there is almost no original pattern here, only like the very small faded pattern. So let's switch to street style. So this one is good. So when you choose street style, you automatically have a number of classes to choose from. In this case, obvious choice is to select tops and maybe pants, right? So because this model is wearing jeans. So let's try this. So just to repeat, in this 10 seconds or something, many things happen. YouTube video is downloaded, the music is extracted from the video, the music is classified, and then the style transfer is applied to segmented clothes. So you can see that this consists of many steps that are going underneath. And
we've got 3 models being loaded into the memory of the GPU at the same time.
Yeah. So it also presented some challenge due to some, I cannot say bugs, but the libraries manage the GPU memory differently. So we had to come up with solutions here also.
Yeah, because one model is in Keras and 2 are in PyTorch.
Let's try on Taylor Swift. Like maybe with some other style, this one. Yeah, different music, I should say. Yeah, so the image is downloaded, which is a good sign already. Okay. Okay, you can see that it's quite nice. Okay, so the live demo is okay, so I'm happy for this.
Thank you. And if you would like to try it for yourself, then you are welcome. We can give you the access to the service.
Or you can come here and try it for yourself. So, any questions for this presentation?
Thank you. It was a very interesting technical talk. I've seen many emotionless and emotion-high women in the pictures. And is this random, or is this the company you work for is only for women? Or have you tested this with men, and how good are the results?
Sorry, that was just a selection bias. It should work as well with the men. But you are welcome to try it if you'd like.
I think from my perspective, women fashion is much more interesting than men fashion. There is a lot more diversity in the clothes themselves. I cannot see any man wearing like this, maybe in Matrix or something like this. So it's much more interesting, and there are a lot more things going on in the pictures themselves. I think this is the main reason why we use women.
Yeah. And it's also based on how we perceive as a gamified initial audience. We know that a lot of our initial audience that potentially will try this are potentially younger female. I'm not saying men is not interested. I mean, including myself, I'm very interested. But that's kind of our initial kind of as what tag as a selection bias. But definitely men's fashion has become very, very trendy now. So we actually tried a few, just that we did not show here as an example.
Any other questions? Is there anybody? Sure, Constantine, please.
Yeah, thanks. And what are next steps? What are plans? What do you want to do with this?
Good question. Actually, many next steps. So the simple one, again, we kind of thinking about blend this into some sort of kind of what we, in a marketing term, we call the acquisition pipeline. Like today in China, there's actually many gamify app in WeChat, which kind of bring in this sort of kind of sweepstake, sort of kind of gamify idea into WeChat, and people can kind of join and play. This is kind of one area we thought that let people join and share, and then kind of see, hey, look, this, just like people do today in all the filtering, kind of stuff, right? So, but instead of do filtering, that's kind of boring now. Everybody doing it. We thought like doing something different. So that's kind of a possible idea. And then again, it's still kind of rough from a business, but we are thinking about more from an acquisition point of view, and not really focus so much about collecting information because always that's sensitive, but just kind of try to be playful, as part of our spirits. You can always come talk to us offline. I know there's a lot of stuff here, but.
How long did it take for over project, and how many images have you used?
How many, sorry?
Images have you used?
For which part? For the style or for the segment? Or?
All the parts.
Yeah, because there are many different pieces. You want to talk about the style? Because there's several. So.
Yeah, so we have created a selection of styles. We started with 150 at the beginning, but then a lot of those styles weren't giving very satisfactory results. So we have then made a selection of a subset by hand, which at this time I think consists of around 15 or 20 styles. And for the segmentation model, I think the full data set consisted of 15,000 of images.
Yeah, segment require more, just because, especially the more parts you need to detect, there's a more training needs to be. And I think style, I remember, it also depends on the type of style images. Some of them require more, some require less, but more or less like 100 is enough. The training is not as much as segment. Segment takes longer.
So many new ones.
Yeah, there's a lot of nuance, but we of course we cannot go in all, but just want to kind of share more from a business point of view.
So thank you for the presentation. So I see that you tried music. Do you try with human podcasts, like a person who is angry, they reflect something, or a person who is happy, or do you try a part of music and another kind of audio?
Just make sure I understand. You mean, are we trying to understand the human? Sorry, just want to make sure I understand your question.
Yeah, because the testing that you did is with music, right?
Yes. Right.
So my question is, did you try with a human audio as well? Trying to
human audio?
Yeah.
You mean?
Yes.
Not yet. Good. Now I understand where you're coming. Yes. There's several of my friends that are actually using that, but not yet applied this. Here we, again, the idea came from Spotify, sort of kind of original idea. That's why we only try music. Of course, I think there's many things we can potentially try, right? I guess if it's represent very different type of max spectrogram, we'll probably have to retrain. But right now it's mainly music. Thanks for Wojtek and Pawel. They just play around a different type of sampling. Yeah, right. The music right now I take from YouTube. I mean, it's not limited to it. It's just an easy API for us to build into it.
Okay, we have time just for the last question. So. Okay, you can go. Please have a mic.
Hello, thanks for the presentation.
Thank you.
So you've told us that the music classification was multi-label, right? So you get multiple genres from one video. So did you try to... So when you apply the style to the clothing, there are multiple labels to apply as well?
So if you have a multi-label output classification for the music, so it depends. So it means that each sample can be attributed to multiple music genres. So in this case, you are able to create a heuristic. Which of those genres would you like to choose? For example, you can choose the one which is given the highest probability the most frequently. And this is one of the heuristics. Or for example, you can create a different heuristic where you will sample one of the genres which are above a certain threshold. So for example, if you have some samples which will be given an over 95% probability, for example, for pop, rock, and I don't know, indie, then you can sample one of those genres. And it will depend on the heuristics you will choose. And in fact, we have 3 heuristics in our service, and you can choose each one of them when you run the service.
Okay, so if I understood correctly, you just select one genre to apply to the clothing.
Yeah, so
all right, okay.
Yeah, we have a set of styles for each genre. So when we have picked a genre, then we will sample a style.
All right, thanks.
We can try see how it happens when we apply multi-style. I'm not sure how that would look like. We have not tried yet. Yeah, it's something we were thinking about. We have not tried it yet. Yeah, but what we've also find out, given what Wojtek said, right, it's a multi-label. In some cases, for example, some of the genres are very close to the others, and so it depends on how the sampling works. Sometimes you actually have a different result. Depends on each time. So that happens, and that's also interesting part, to show a different variation. So, okay. Thank you.
Thank you.
Okay.